Okay, here's the national NC-98 that I'm working on restoring. And here's a view from the top side, pretty dusty, few extra spiders in there, and cosmetically in pretty darn good condition. Here's the bottom side, all original capacitors in here. I did notice one of the ceramic trimmer capacitors was completely broken and that part missing. So I'd have to look through my collection. Mostly tiny cheap capacitors in there. One electrolytic here, and then the main filter capacitors here. More capacitors. And then looking again from the top side. And looking through my collection, I was looking to see if I could find some trimmers that would be the correct value. Found this old FM tuner chassis, and it had this trimmer capacitor right here that tested in the right range. According to the manual, it requires 5 to 20 picofarads. This one was about 5 to 25, so that would do the job. So I pulled it off this old tuner chassis and soldered it into place. So there it is next to the other ones. And then this is another view of the bottom side here. So next to tackle is the power transformer, the filter capacitor. It's a multi-section capacitor with three 20 or 22 microfarad 450 volt capacitors in one big can. So I took some pictures of the bottom side of that. And what I'm going to do is clip the leads on that and install the capacitors on the bottom side, leaving the can on the top original, but disconnected. So getting ready to tack in the new capacitors here. And this is before soldering them all down, but just getting them into position. And putting a little solder on those. And then next thing I looked at, the plug. It looks a little bit it's iffy. Some of these wires were a little too close together. I was thinking that might short out. So I took that plug apart and cleaned up all the wiring there and put it back together. Then I went to measure the main power transformer to make sure it was still good, not shorted. Seeing 3 ohms there, so that seems like it would be good. And then went to replace this electrolytic capacitor here, 22 microfarad, 50 volt, and the new one there, much smaller. So here's a picture again of the bottom side, got the filter capacitors replaced in there. And then I'm starting the recap of replacing individual tiny chief ones, and I'm using the J-hook method. So cut the old one out and hook it around the same leads there and solder the new one in. This one being new, and this is an old one here. So just going through replacing these. These domino capacitors are micas, so most likely they won't need to be replaced. I did find this one resistor here. It was, I think, a 2 or 3 watt resistor, and it tested something like 60K when it was supposed to be 40 or 39 or something like that. So it was way out of tolerance, so I replaced it with one of these newer style 5 watt resistor. So lots of them around here. This one specifically had some yellow tape on it, as in it was just floating in the breeze. So why somebody disconnected that, I don't know. And I had to go to the schematic to figure out where this actually goes. And I believe it actually went here to the phono input. So moved it out of the way and then soldered in the new capacitors. We got all new capacitors in this section around the on-off volume pot. This one I decided to install a fuse in it because the radio doesn't have one, and so that's just good protection. So I put that in the hot lead of the AC, going connected to the switch. And more going through, just getting rid of all the wax paper and electrolytic capacitors here, replacing them. Here's a bag full of them, even the big ones here. Next, looking at the tubes. So going through my tube collection, the ones in particular tested weak were 6CB, CB6 or 6CD6, I think it was. And I had to look through and see if we could find those 6BD6. Yes, that's the tube, and got out the trusty Hickok tube tester and checking those out. And going through my collection of tubes here, this is just a small amount, looking for that specific tube. And of course, I couldn't find any of those. But I did find that there was an equivalent, and I believe it was 7549 was the equivalent. So I found 2 of those, and they tested good, and I put those tubes in. The other tube on the radio that was incorrect was the rectifier tube. In this original position here, it had a 5U4, so I believe that used a lot more current, so I replaced with the factory original 5Y3 and tested all these tubes. I ended up replacing 4 of the 9 tubes in there. And then turn it on its side, and so I can access both the top side and the bottom side. Getting ready for an alignment. I powered the radio up, and it definitely turned on, but the receive was a little lacking, so I figured it needed a full realignment. This is a dim bulb tester that I built and put together. Has a variac here, the current draw here, and the volts here. And there are all the tubes glowing. Let's see here. So that's a little bit of sideband on probably 40 or 80 meters. And the dial lights were all burned out. So that was another thing I had to look through my collection to find some GE47 bulbs. I found this carton of new old stock ones. So I stuck them in there, and wow, it looks so much better with the bulbs in it. There's the fuse, which, by the way, I installed, I believe, a 1 amp fuse just in case. So 1 amp seems to be perfectly adequate. So I'll just leave it at that. There's a picture of it lit up in the dark. It's such a beautiful radio. So the next part will be the alignment. So I have a Hewlett-Packard AC RMS voltmeter. That's going to be hooked up across the speaker leads. And then that's going to show you the strength of the audio coming out, so you can adjust things. And then you adjust the voltage range here, the gain and the volume on the radio to keep this in the range so it's not maxed out. And then I also used an isolation transformer here, just for good measure. And then here's my CT Systems 3000B service monitor. And what I'm using this to generate the IF frequency and go through the procedures of the manual for alignment. And it says you need to find what the 455 kilohertz IF crystal frequency actually is, because over time that crystal will drift, and it gives a procedure on how to do that. And basically you just hook up the and generate a signal in there, and then you just keep adjusting your frequency up and down until you see a marked peak on the VTVM, and that will tell you where your IF frequency is. So this one had drifted from 455 to 452.6, or right around there. And then you start adjusting the specific trimmers and IF cans and slugs so that you can peak that out now that you know the IF frequency. So 452.7 kilohertz, yes, 452.7 turned out to be right where it was. Next procedure, you inject a modulated carrier into it and adjust things. So there's some modulation going in there. And then you feed it in through a capacitor to the, I think it was the stator of the main tuning capacitor. And this is just listening to AM 1530 and seeing how close it is on the dial. So you go through the procedure to tune all those trimmers and slugs, and then it is aligned. So here's a quick tune through some of the AM broadcast bands. So after the full alignment, it is working like a champ, pulling in signals, and all these signals here are with a 40-foot piece of wire. So very, very good. Here's a picture of it, all buttoned up and working like a champ.